Hi, everyone. Welcome to Chapter 9, Section 3, Two Dependent Samples and Matched Pairs. In this section, we are going to be presenting methods for testing hypotheses and constructing confidence intervals involving two means. But now remember, we had in Section 9.2 when the means were independent. Now in this section, 9.3, the population means are dependent in the sense that the data consist of matched pairs. So in this section, we have dependence or data that consist of matched pairs. The pairs must be matched according to some relationship, such as the before and after of the same subjects or IQ scores. So we're going to be looking either at the same subjects or they have to have some sort of relationship. Let's begin by talking about a good experimental design when we're dealing with these types of population means. When designing an experiment or planning an observational study using dependent samples with matched pairs, it's usually a better one than using two independent samples. Inferences about differences from matched pairs. So what is the objective of this section? We are also going to be doing hypotheses tests. We're going to use differences from two dependent samples or matched pairs to test a claim about the mean. So we're still going to have a null hypothesis and H of one. That's going to be your alternative hypotheses. We are also going to have a confidence interval like we had in sections 9.1 and 9.2. We're going to look at the differences from the two dependent samples or matched pairs, and we are going to be constructing a confidence interval. For that, we are going to need notation. So this is a new one. D is the individual difference between the two values of the single matched pair. So we're going to look at the differences between the means. We're going to look at MD, which is the mean of all of the differences for the population of all matched pairs. So we're going to have the population of all matched pairs and then D bar, which is going to be the sample data from the matched pairs, the standard deviation of the differences for the pair data, and N, the number of pairs in the data. So now N will consist of pairs, and this is section 9.3. Okay, so not just unique values, but actually pairs of sample data. What are the requirements for us to be able to successfully use the notation and identify that we have a matched pair situation? First, the sample data must be dependent or matched pairs. That's the first condition. The matched pairs are simple random samples. Either or both of these conditions are satisfied. The number of pairs is greater than 30, or the pair of the values of the differences must have an approximation that is normal, like a normal approximation. Okay, so we have to have an approximately normal distribution for us to be able to use this requirement. These methods are robust against departure of normality, so the normality portion is loose. Now, this method of matched pairs has a test statistic that's represented by the difference, the sample differences minus the population differences divided by the standard deviation of the differences over the square root of n. We are also, this is going to be the test statistic formula. Again, you don't have to do this by hand. We will not be asking you to do this by hand. We will be using StatDisk as well. We are also going to be finding p-values. Those p-values will be identified using your TI-83 or TI-84, or in this case, by StatDisk, or a t-distribution in table A-3. So the test statistic is actually going to be a t-score. Okay. So when we're looking at dependent samples, we are going to be looking at a t-score. The critical values, we are going to be finding that using our table A-3 with degrees of freedom n-1, where n is the number of pairs. So we know how to use table A-3. We are going to be looking at the critical values and alpha. Excuse me, to identify the values of your t-score. Okay. Now, when you want a confidence interval, this is the actual formula. It's D bar minus E less than the mean difference less than the sample difference plus the error, where the error is actually going to be a critical t-score times your standard deviation of the difference over the square root of n, where your degrees of freedom is n-1. Again, we are going to be calculating the confidence interval using StatDisk. So StatDisk will help us find the t-score, the test statistic, the critical score, and the confidence interval. So let's begin. What is the procedure for inferences with dependent samples? We need to verify that the sample data consists of dependent or matched pairs and verify the requirements are satisfied, meaning that n is greater than 30, or we have a normally distributed approximately. It must be a simple random sample. We need to find the difference D for each of the pairs. We need to find the sample of the difference in the standard deviation. For hypotheses test and confidence intervals, we're going to use the same t-test procedure for a single population mean. Okay. So we are going to be using the same hypotheses test and confidence intervals. Okay. Now, this is important because so far in a population proportion and a population mean, the equivalence methods were different. So let's look at 9.3. Because hypotheses test and confidence intervals in this section is the same distribution and standard deviation, they are equivalent in the sense that we will land in the same conclusions. Consequently, a null hypothesis that the mean equals 0 can be tested, determining whether the confidence includes 0 or not. So when it does include 0, then you do have a significant difference. So here in section 9.3, we have equivalence. We also had equivalence in section 9.2, not in 9.1. 9.1 was so far the one that was not equivalent, proportions. So let's begin by looking at the following example. Are best actresses generally younger than best actors? So we're given a data list of ages, actresses when they won Oscars in the category of best actress, along with the ages of actors when won Oscars in the category of best actor. The ages are matched according to the year that the awards were presented. This is a small random selection of the available data so that we can better illustrate the procedures of this section. Use the sample with 0.05 significance level to test the claim that for the population of best actresses and actresses, the difference have a mean less than 0. So the mean difference is less than 0. So that would be our alternative hypotheses. And our null hypothesis is that the mean difference is equal to 0. That would be our alternative hypotheses. Now we have to check how many we have. We have 1, 2, 3. How many? So what's n? N is equal to 1, 2, 3, 4, 5. N is 5, which is less than 30. If we look at our data, can we say that this is approximately normal? Well, if we look at the actress and actors, we can identify that they do have a relationship and that it's normally distributed approximately. So we found h of 0 and h of 1. We know that n is 5. Now we notice that there are the differences 1, 2, 3, 4, 5. We have to find the mean of those differences. So let's look at the requirement. N is equal to 0. This is dependence because they are matched. They're matched pairs. You do have normality. There's no outlier, so the requirements are satisfied. What you want to do is you begin by looking at your p-value. You can do a t-test where you substitute the value. So if I want to go into calculate 84, so let me share my screen. So if I want to use this formula, I'm going to go to second, let me quit. You're going to go into stat, test, t-test. So you're inputting the mean, the x bar, and this is your alternative hypotheses. Is less than, okay, here, n is 5. We want to find the standard deviation, the mean, so we're going to have to input the value of the difference. So let's go back. Okay. So let's go back here. We would have to use, if we want to do it step by step, we begin by looking at the claim that the differences have a mean less than 0. So we have MD is less than 0. The original claim is not true. So the null hypothesis is the equality. There's h of 0 is equal to 0. MD is equal to 0. And the null is MD is less than 0, the original claim. We have a significance level alpha of 0.05, and we will use the student t distribution. So before finding its value, we must find the values of d bar and st. So d bar is the mean of the differences. D bar is the mean of the differences. So what you're going to do is you're actually going to go into calculate 84, and then you're going to clear. You're going to go into stat, edit, and then you're going to remove L1 and L2. You're going to go into L1 and you're going to put in the values of the differences. So if we look at our values, it's going to be negative 34, just the differences, negative 9, negative 5, negative 9, and 6. Remember, where are those numbers coming from? It's actually the difference between actress and actors. So if you look at this table, 28 minus, subtract 28 minus 62, we get negative 34. 28 minus 37, negative 9. 31 minus 36 is negative 5. 29 minus 38 is negative 9. 35 minus 29 is 6. That's where we're getting the differences between each of them. Now that we have L1 data, we're going to go into second quit, stat, calc, 1 vars test, hit enter, and then we're going to find this X bar is actually D bar. So X bar is actually to D bar in this section because we're looking at the mean difference. So that's going to be negative 10.2. The standard deviation, which is SD, is going to be 14.65. So let's write that down. And then once we have that information, so let's go back to our values over here. So now that we have, remember X bar in this case is D bar, it's negative 10.2, standard deviation is 14.65 or 14.7. We can round to one decimal. So now that we have this information, we can go on to StatDisk and identify our values. So let's go ahead and do that. So I'm going to open up, you're not going to have to do this by hand. We know that alpha is equal to 0.05. We know our matched pairs, we know everything. So that's the first thing we need to do. Find out the pieces of the puzzle before we can continue. So the first thing you want to go is into StatDisk. So hopefully you guys are all looking at my screen. You're going to go into analysis, hypotheses testing, and then mean matched pairs. And then you're going to go, the mean is less than 0. And then we are going to give you the significance. And then here you're actually going to put in the two data values. So we're going to put in the first 28. This is the female, the actress, 31 in a table, 29, and 35. So that's 5. And then the next one is going to be 62, 37, 36, 38, and 29. And then you're going to compare data 1 with data 2. Oops. Column 1 with column 2. And then you're going to select evaluate. And then there it is. It's going to tell you this, the alternative hypotheses. There's the D. There's the standard deviation. There's your test statistic. There's your critical t-value, your p-value, and your confidence. This is everything that you need. I'm not going to ask you to do it by hand. You will be able to use StatDisk, and I would want you to. So then the first thing we want to do is look at our p-value. Given that my p-value is equal to 0.09, well, is p less than alpha, p less than or equal to alpha, or p greater than alpha? Well, 0.05 is actually 0.09 is actually greater than 0.05. So then we can say that we are going to fail to reject the null. So we do not have enough evidence to support the claim. Or we can also look at our test statistic, negative 1.55. So if we look at the critical regions, we have negative 1.55. And then my critical T is negative 2.13. So positive and negative. So negative 1.55 is outside the region. That's another way we can verify that we will fail to reject. And then looking at the confidence interval, this is a 90% confidence interval. We can find the confidence interval of negative 24.16, less than the mean of the difference, less than 3.7. And notice that 0 is in between, so there is going to be a significance. So all of them matched. We will fail to reject the null. So looking at what I have down here, the p-value was 0.09. We look at our conclusions, the p-value was greater than alpha, so we will fail to reject the null hypotheses. We also look at if it's in the region or outside the region. We have negative 2.13, our critical values, and our test statistic is outside the region. That means we will fail to reject the null. In addition, we found the confidence interval that gave us a 0 in between. This is a negative number and a positive number. There is a 0 in between. That means that you do not have enough evidence to support the claim that the mean difference is less than 0. So again, there's not a sufficient evidence to support the claim that the population of ages have a mean difference of 0. Okay? That would be our conclusion because we failed to reject the null. There it is. We construct the same data using a 90% confidence interval, which we already have. You can also use this T interval using your TI-83, TI-84 of how to use your calculator for that. Again, you're going to go into the T interval. So I'm going to show you. So let me close that. You can use that stat test and you want your T interval right here. So let me close it again. So stat test, and then you're going to look at T interval.
Need better internet than 5G? Well, search is over. Get Cox Internet for just $40 a month when you add Cox Mobile. It has faster.
Sorry, as you guys know, when you use Calculate 84, if you don't buy the full access, then you get ads. So that was an ad, sorry. So you're gonna go into, let me clear it again, stat, test, and then you're gonna go to T interval. And then you're gonna put your data L1. You're gonna put your values, and then you're gonna want the confidence interval to be 90. There's N, so you're gonna change in the values here. So technically X bar will be your D bar, which would be 10.2. Your standard deviation was 14.65. And then we have to put in the data. So we need to put L1 and L2, or the stat, whichever one. And then you hit enter. Calculate, it's not letting me, and then there it is. So all you had to do was input X bar or D bar, the standard deviation, N, and the confidence level. So this was a 90 confidence level. There's your values, -3 and 24. And I don't know why is it backwards. Hold on. So this should be reversed. It should be -24.16 and 3.7. So there's our 10.2. Oh, I think it's because it's not taking the hypotheses test. It's not looking at the MD is less than. I think it's taking the other way around. Let me go to second, clear. Let me go to stat. So here we have the t-test first. This is equal to 0, the null hypotheses. This should be 10.2 and 5. Okay, let's hit enter. Let's hit calculate. Okay, there's our value. There's our p-score. So we have our mean difference. We have our t-test. 0.9, it should be 0.09. So let me go back to StatDisk. 0.09. So there's the mean difference less than 0. 0.1. Let me look at the editor, making sure all the values in there. There's a result. Mean D is less than 0. That's what I want. There's my sample size. So there's a glitch on the calculator. I want t-test is equal to 0. That's their null. The mean difference, what it is, D bar X of the standard deviation, and then N. They have the data for L1 and L2. I didn't put it in there. So I'll send you guys the recordings for this, but I would just stick to StatDisk. It's interesting because if I go to stat and then test, I want the T interval. So it's going to take my data, L1. Let me see if L1 is my value. L1 should be the differences. So let me go to stat, edit, and that's the one that I want. -34, -9, that's the one. Test, T interval, there's my L1, my frequency. Let's see if I will calculate it this way. Okay, now that's the one that I want. So let's do that instead. Let's look at the T interval, but instead of going into, so again, it was stat, test, T interval. We're going to put in the data. So make sure we look at the data, not the stat. Go to data. L1 should be the differences that we put in there, the frequency and the confidence interval. Hit calculate and then enter, and there it is. There's your D bar, their standard deviation, and your confidence level of a 90%. Okay. Which still give us the same conclusion that we will fail to reject since there's a 0 in between. So they both give us the same result. Okay, this is using our TI-83 and TI-84. If you would want to manually compute the margin of error, you could. Remember, your T-score is given in StatDisk. So there's your critical T. You could have used your critical T. And then you would substitute the standard deviation right here. Divided by the square root of n, you would just take the square root of 5 and then actually evaluate it. And that will give you your confidence interval. But we already knew what the confidence interval was, doing it manually and doing it using StatDisk or your calculator. So what is the interpretation? We have a 90% confidence that the limits of negative, so remember this is one of the limits, the lower bound, negative 24.2 years and 3.8 years contain the true value of the mean of the age of the differences. In the long run, 90% of such samples will lead to a confidence limits that they actually do contain the true population mean of the differences. The confidence interval includes the value 0, so it is possible that the mean of the differences is equal to 0 year, indicating that there is not a significant difference between ages of best actress and best actors. Okay. So at the end of the day, we might have some overlap, if you will. What happens if n is less than or equal to 0 and it's not normal? Then we would have to use the bootstrap, which was in section 7.4 that we did not do. We did not. So don't worry about bootstrap. We would only do bootstrap if you do not have something normal and n is less than or equal to 30. And that finishes section 9.3. I will stop the recording now.